Now see here temperature dependence of resistivity and resistance also here. So we have seen the resistance of a conductor depends on the temperature. Similarly, the resistance and resistivity of the insulators or semiconductors depend on temperature. So actually the conductors are those materials which conduct electricity properly, has got the large number of the free electrons, and their resistivity is lesser one. But if you have taken the semiconductor which has got the resistivity greater than the conductors but less than insulators, so their conductivity lies actually between the conductors and insulator is known as semiconductors. Examples are silicon and germanium. Insulators are those materials which do not allow to the flow of current. So how does their resistivity change with temperature? So now see here, there is a relation for temperature also we can take, like RT is equal to R naught into 1 plus alpha delta T here. R naught is here the resistance of the body at the reference temperature, RT is the resistance of the body or the conductor at temperature T, and alpha is here called here the temperature coefficient of resistance, and delta T is called change in temperature. Similarly, we can write this relation for rho T is equal to rho naught into 1 plus alpha delta T. Here rho naught is the resistivity at the reference temperature, rho T is the resistivity at the temperature T, and alpha is here the temperature coefficient of resistivity, delta T is the change in temperature. So now for the conductors, as we have done, resistivity increases on increasing the temperature. So in that case, for the conductors we can draw the graph, here the resistivity and here temperature in Kelvin, and the graph is something like this. So this is the variation of the resistivity for conductors with the temperature. This we can write here for conductors. But if you have taken it for alloys, it is here rho and T, it is like this. There is a small increase in the resistivity of the alloys. Examples we can take here, alloys may like this is here the nichrome or Constantan wire or manganese. So here the resistivity increases, but it's there is small increase in resistivity with rise in temperature. But if you are taking insulator or the semiconductor, you will be getting the variation like this is here T and rho, and the graph is something like this. So resistivity of the semiconductors or insulator decreases with the rise in temperature. So the value of the temperature coefficient of resistivity for a conductor is positive value and it has large value, but whereas for alloys it is positive but it has got a less value, a small value, but for the semiconductor or insulator alpha has got the negative value. So this is the actually temperature dependence of the resistivity of conductors, insulators and semiconductors.